things that have been added in along the way, but basically right now there's still pretty much, I mean, parametric equations you guys didn't do, and it was in the beginning of their book. Polar equations you don't do, and it was kind of in there a little bit, but they haven't gotten to the new stuff yet. Okay, or the advanced stuff yet. Per se. We are in section 2.6a. Sorry, CalcAB kids. We were talking about CalcBC and why they had a 2-day test. All word problems. Whoop. That's okay. I had an all word problem class in college. That was way more fun. My book was about this thick and about this big. It's like an English reading book, but guess what it all was as you flip through it? Just word problems. That's it. No sections, no examples, just anything you've learned in math, use it to do. We had to. However, you guys had a section in your chapter 1 in pre-cal, section 1.10, mathematical models. That was the name of my class. But your section was way easier than my class. Anyway, here we go. What are we doing on Monday? Quickly doing pre-cal review so that we can do the calculus derivatives and inverses. Okay? Things like, pre-cal says they reflect across, they meaning inverses, reflect across y equals x, or you switch the x and y, solve for y, or you do f inverse of x, yay. F inverse of f equals x, and f of f inverse equals x. Domains and range are switched, and so do the points. That was like 4 pages in pre-cal notes. HLT, that was another 2 pages. And then we had this whole continuous and, remember how the AP likes to ask concept-y questions? Yes. Remember the AP classroom where we were doing the multiple choice and you're like, and you saw continuous differentiable, and I'm like, that's why there's a forever card? That's why we have to talk about that. And then, does it start to get blue? Yeah, there we go.
Wait, so are we not writing?
This is where we're going Monday.
Oh.
Quick through the pre-cal. You already have it written down? Sweet, we'll just go. And then let's slow down on the calculus. Whoa! I mean, differentiability, this is still kind of like the forever card concept-y, but then, what are we going to be doing? Finding the rule to derivatives of inverses using who is this guy? You guys should recognize him. Tangent line. Oh, that's cool. We can use a tangent line to find the derivative of an inverse. The answer is yes, but that's not our goal for today. If this was a full day and not a minimum day, we would have actually started off class maybe still taking notes, but probably not. I think we would have done this first and then notes instead of notes first and then this. You guys recognize this, yeah? What would I have told you to do? Back of your homework spiral. 3 multiple choice. Let's go. You try them on your own, my ones that always work together, and then grade in your groups. I love you, though. Them too. And actually them over there too. Anyway, basically all of us. These 3 you would have tried. Now hold on. You would have tried. Does that mean you're not trying? Or does that mean you're trying it a different way? What's your homework this weekend due on Monday? Work out the following 2.5 multiple choice problems. Wait, there are only 3 of them. You come in the back of your homework spiral. It's not another homework assignment in the back of your homework spiral. But wait, so what are you attaching? Just those 3 problems? Then, doesn't say mark is done. Then, watch the attached video showing the idea of, do you see what this title is?
How to find derivative of inverse function.
In this video, I'll show how to find.
I know. It's going to be a little dry. But he does get to use fun colors, and the fun colors are kind of helpful. But, listen, 6 minutes and 31 seconds. You can actually do the homework, yeah?
Yes.
Okay, and not skip it? Because it's important for what we're doing Monday. Good? 3 multiple choice problems in 1 video, and you're done. Sound good? You're going to do it?
Yes.
Okay. Yes, none of you answered the sound good part. Love you too. All right, so here we go. Boop, boop. Let's, instead of doing that, and instead of doing all kinds of that, let's go ahead and do this. Let's grade. Don't you guys have some evens from logarithmic differentiation? Here we go. Number 66, you need to grade. And we need to talk about where you got stuck in homework and couldn't make it match. Oof. This would have been a beast. X plus 1 times x minus 2 all over x minus 1 times x plus 2, a quotient rule with 2 different product rules. And factors that got to be squared over bottom squared for the quotient rule. Ugh. Ugh. Now, just a few of you would have been like, there's no way I would have done that with a quotient rule and 2 product rules. You kidding me? I would have FOILed the top, FOILed the bottom, and then done quotient rule. Okay, that's a novel approach. But either way, whether you would have FOILed, and then taken a derivative quotient rule, or taken a quotient rule bottom D, oh, stink product rule, minus top D, oh, stink another product rule, all over bottom squared, doesn't this look at least a little bit nicer? ln of both sides. Break it up using your product property and your quotient property. Quotient, I need to subtract both because they're both in the denominator. And then all I have to do is, what is the derivative of ln of u?
1 over u times u prime.
1 over u times u prime. 1 over u times u prime. What? Where's the u prime? Times 1. Oh, 1 over u times u prime. Ah, it's 1. 1 over u times u prime. Ah, it's 1. 1 over u. Oh, this was an easy problem. All the u primes were 1. Then what? How did he get over? Where did he come from? Multiply the y, and then they plugged in the y. You see it? But what was all of this? Oh, I think I see common denominators. Oh, I think I see common denominators. Oop, I think I see factoring, hoping to simplify some of them away. Oh, step. Dun, 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 dun. Now pause. Remember how I said on the AP, if it's logarithmic differentiation, they would have multiplied the y on the other side, plugged in, and then been done? So technically, this would have been okay for the AP. But what are you trying to do? Make it match. Hence why you had to get common denominators. Let's get rid of that, and let's go to number 70. Final answer is, look. This is an AP way. See it?
Yes.
They multiplied the y, and then they plugged in the y. This is an AP way. They multiplied the y, plugged in the y, and said, done. Yeah.
That's legit.
Yeah.
You probably answered this before, but how do you know when you need to use logarithm?
The nice thing is on the AP, the only time you need to use it, aka the only time the answers will look in this form with the y multiplied and then plugged in, would be when they actually said use logarithmic differentiation like homework did.
Oh, so you'll know when you're supposed to.
Yeah. Well, that was true in number 66. Do you guys see the directions on the 63, 4, 5, 6? It said logarithmic differentiation, right? But hold on, look at number 70. What were the directions?
70.
Oh, under the same section?
Yeah.
Okay, but here's the problem. On the AP, it could have just said, why could it just say find the derivative? And you had to use the can't handle it, right? Can't handle it until you bring it down, and you can't bring it down until you have it. So whenever you have an F to a G,
And you can't handle it
because x to the n power rule doesn't apply because that's not a
because it's a
constant.
lot of work.
And b to the u doesn't apply because that's not a constant. The base isn't a constant, the exponent's not a constant, power rule and b to the u are both illegal. I can't handle it until I take it away. Gotta bring it down.
And so logarithmic differentiation, that's always, you always use that.
Yeah, whenever you have, well, it's required and won't be stated whenever you have something like this. Because I have to do ln to bring the g down to make a product rule I can do, as opposed to this weird what I can't do. See it? So that's the one time they will not tell you use logarithmic differentiation. I can tell you that right now. They'll just give it to you and try to trick you. Okay, number 72 was another. They didn't have to tell you to use logarithmic. It was implied. The only legal way, the only way to handle it. I had to throw in ln's and bring it down. Now, the problem was, how many ln's were there?
Like a lot.
But, let's take it one at a time, right? Can't you do second D first, which is this guy? Remember, they write it in different orders than us. So second D first plus first D second. Here's where it got a little iffy. Some of you might have, for triangle prime, gotten a little lost. Because for triangle prime, you had to think about your y equaling ln of u, and then your u equaling ln of x. So then y prime times u prime was 1 over u times 1 over x. And who was u? That's how they got triangle prime. But either way, at that point, I think they just reduced, and then 1 over x plus ln of x over x. They just pulled out the common 1 over x. So I can get my green pen out and say, what's in common? The 1 over x was, which is why he came out. But then they weren't done. Because over here, chilling, even though they didn't write it, it was right up here. There was a 1 over y dy dx, which is why there came another part into play. Because they plugged it in. There it is. Oh, number 80. You guys had one more. Oh, Siento, I apologize. She's right here. The slope is greater, aka steeper, at x equals -3. There are vertical tangent lines, aka, right? Vertical tangent lines, infinite derivatives, undefined slopes at both of those points. And there's a horizontal tangent line about. There's a place where it reaches a max or a min. It levels off around 0. The point 0. Okay, can we go over any questions? Maybe? Maybe not. Do you guys have anything? Like any burning one where you're like, I thought I had it and I can't make it match. I followed the rules and I don't know what's wrong. Anything? From beginning to end of 2.5? Yeah.
I had one number 51 in the first section. It was on like the second version.
Oh, 51. Perfect. I hope we could get one covered.
Because I did it and I got the first derivative and I was going to do quotient rule, but it did something else, so I didn't know what to do. So.
Okay. So on number 51, x squared minus y squared is 36, right?
Mm-hmm.
Supposed to find the second derivative?
Yeah. But I got the first. It's just x over y. But then they did something funky.
Here's what they did. They said, take it as it is, right? Just as you are. Then, when you moved, you got, which they did too, to be honest, because they wanted you to be able to check and make sure you got the first derivative, right? But even though you could go quotient rule from this step to derive again, they actually said, or you could just take it as it was and derive right here. So when they go to the next step, they're actually going back and saying, haha, I like him better. Derivative of 2x is 2. Derivative of, now they have to do a product rule, whereas you would have had to have done a quotient rule. But for some reason I like that better. So second d first would bring out actually 2 dy dx's. Plus first, now careful, the minus is to everybody. You have to distribute first d second. Now I know it looks different, but to be honest, it should end up being bottom d top minus top. It should end up being the exact same. They just don't have a complex fraction, but they have complicated other stuff to deal with. Either one of you, no matter how you do it, you're going to have to take that dy dx and either plug in here or plug in here. Both of them need plugging in. But when you simplify, they should be the exact same thing. So if you like quotient rule, go for it. Just beware the complex fraction and how to simplify. But if theirs makes sense, you wouldn't have to deal with a complex fraction. You could just simplify as is. This would end up being y minus x times x over y. Which hopefully you would see that little entrenched y that can't reduce away. So you would do a little complex fraction deal and get y squared minus x squared all over y cubed. But just because I remember something from back here, I'm pretty sure they wouldn't stop there. and they would end up saying, oh, isn't that just negative 36 all over y cubed? What the crud? Why did y squared minus x squared become negative 36? Oh, that's right. Whatever was given in the beginning can be used at the end. Now, do you see how your signs were switched? So technically they just said, oh, hey, if you switch the signs and pull out a negative, you'll have y squared minus x squared. Hence how they got negative 36. But this does. I know. Happy minimum day. Come Monday with further questions. Period 1 didn't get to really ask either, but you could also use math lab hours, etc. to ask me homework questions too. This weekend, watch a video, 3 multiple choice. That's it. Bye guys. Of the 3 multiple choice. Good job, guys.
Happy Meal Day.
I got an email from Mr. Williamson that said that you weren't I also got the contract. Try to log in. Reach out to Tony or someone if it's not working. But you just want to get into College Board and then put in our class code and make sure you're focused.
I'm just gonna come back for 7. So